Okay, so sorry for the late start. So this is first time teaching this room with a new technology, which actually was not exactly the same setup that was in here just last week. In fact, certain things that I thought would be here are missing. So what I can see, nearly all the close students are connected. Hopefully everyone will catch this later. So kind of the way it works is that anyone in the close classroom would need to call up here. It doesn't work for me to call down there. Okay, so it looks like we're all set. You can see my screen good. Today will be the first day of the MATLAB tutorial. So for the next 4 class meetings, it's all going to be about basics of MATLAB. So apologies to anyone who already knows MATLAB. So that might find it boring, but it's something that definitely will be essential for anyone who does not have that experience. Okay. So the first homework assignment is all about MATLAB. So as you go through the textbook, I'm actually going to go ahead and share that for a moment. That open here. Okay. Okay. So in chapter 1, for section 1.2 is where the tutorial begins, and that's what I'll be starting with, and taking you through these things and providing some explanations and certainly answering any questions you all have. I see some of you here have your laptops here, but that's good, so then you can try to follow along and try things on your own as I'm doing them. That'd be a good idea for the next few class meetings too. So as we go through the tutorial, what you'll see is these explorations that are interspersed throughout the section. And those are the problems for the first homework assignment. Not all of them. You can find the list in Canvas or on my site. So what I would suggest is, as I go through the tutorial during these 4 class meetings, go ahead and get started pretty soon on problems that come from the sections that I've already covered, so that you're not having to do a whole bunch of them close to the due date. Okay. I think number 1.2.28 is the last one that I've assigned. I'll flip back to MATLAB. I'll see something in the chat here. Okay. As far as the microphone is concerned, well, there's this one, but I'm not sure if it's working. Okay. Yeah, there's certain microphones that are interspersed on the ceiling. So, yeah. Okay. If I speak sufficiently loudly, those of you who are connecting, are you able to hear me okay? I know it's a little more difficult when I'm behind a mask, but there's a microphone here at the podium. I'm not sure if it's active, but I moved it closer to me. So, okay, and maybe. Yep. Okay. Are you able to hear me at this point? Anyone who was having difficulty earlier, please let me know, one way or the other.
I can hear you.
Okay. I'll do my best as I can to. This is actually my first time teaching while masked. because I was all online last year. Not everybody was, but I was. Okay, so. So I just realized that I don't have. I need to get another document open here. Okay, so what I'm doing, so often I'll be doing MATLAB demonstrations throughout the semester. I mean, these first few classes, that's all I'll be doing, but even other times I will too. And one thing I want to make sure to remember to do, and feel free to remind me in the future, just like I may need to be reminded about recording, things like that, is that I want to log everything that I do in this session. And so the first MATLAB command I'm going to show you is the diary command. I'm going to make that text a little bigger. I recall I needed to do that previously in this class. Okay. So the diary command, if you just use it by itself, then it will create a file that's simply called diary. And all of your commands that you type in this command window, and also the output that they generate is written to that file. Now, I don't like to use it that way because it's better if a file has an extension. So what I do is I can apply an optional argument with a .txt extension. It's just going to be an ordinary text file. So today's at 26. So that's what I'll name my file. And I will post this file in Canvas and on my website after. Okay, so now, and you see over here to the left, we have all the files that are in the current directory. So up here, you see the directory that I'm currently in. So I created a directory just for this tutorial that I'll be using for these couple weeks. And you can see the files that are in that directory. One of the most common problems that newer users have with MATLAB is that when you're trying to access code that's in certain files, and we'll talk more about those files later, it's important to keep in mind that those files need to be in the same directory that you're currently in, or they should be on your search path. But for purpose of this class, be sure that the directory here matches the directory where your files are, so that it'll find the code that you want to use. So that's a common mistake. Down here we have workspace, where it will list variables that you have. We don't have any yet, but we will momentarily. And over here, command history. These are the commands that I've done recently. Here's the latest one I did. So you can actually highlight commands and run them again. So it's quite convenient for that purpose. Okay. So that's the first useful command, diary. Another useful command is, well, the help command. If you just do help by itself, oh, I did. That's really odd. Yeah, I didn't want that. They've changed their behavior on me. I hate that. So,
maybe help. Well, it is MATLAB. Help.
True.
Yes, you will.
Well, that's it. No, okay.
MATLAB
has conspired to, the math works have conspired to embarrass me. It may be something to do with a long ago email fight I had with with her creator, but still. I'm not kidding. What it used to do is list all the possible categories of help that you could get. So, like for example, help ops, sort of all different operators that are available, like arithmetic operators, like relational or logical operators, which I'll be showing you probably next Tuesday. Punctuation, and we'll get into some of those later today. And also set operations, ones you know from other math courses like union or intersection, that are quite convenient. So the trouble is, the help command by itself will list the categories. So, and now it doesn't do that anymore. It's unfortunate. Okay, and certainly you can get help on a particular topic, like, for example, the equals operator. Now, equals, like in certain other programming languages like C or C++, is intended for comparison, to test if two entities are equal. But you also have the EQ function that will do the same thing. So you can either do A equals B for comparison, or EQ, a function EQ with A and B as arguments, and it'll return a value of true or false, so 0 for false or 1 for true. Again, like in other programming languages. Okay. Now, what we see here, notice here it says reference page for EQ. So if I click on that, you know what? It might not show that because of how I'm sharing. I'm going to share my entire screen. So if MATLAB pops up another window, then you'll see it. So if I click on this reference page for EQ, it opens the MATLAB documentation window, and I'll have a more detailed documentation page for whatever you were just getting help on, including examples, references. For example, if you are looking up a function that implements some well-known algorithm, you can get a reference, like a journal article about that algorithm, and get all the details of its implementation. So there's a lot to say about a simple operation like EQ. So all the information is here under the reference page. All right. Actually, you can do the same thing. Oh wait, you get rid of that. Okay. If I do doc, that also will open that same reference page that I was just showing you. That's how you access the full documentation. So what I'm going to do now and then, as I'm going through a tutorial, I'm going to use this. A percent sign is used for comments. So after a percent sign, I can type whatever I want. That's a comment. MATLAB will not process it. So it's used to document your code, for instance, like in other languages. So help will give you a brief help page. Use doc for full documentation on whatever command you want help on. All right. So now what I'll do is I'll get into some very basic operations, just to tiptoe into MATLAB and all the mathematical tasks that it can perform, and also working with variables. Okay. So sometimes I actually use MATLAB, because I always have MATLAB open for some reason. I use that as like a desktop calculator. What I'm doing here is performing the operation, and the result is being stored in the variable A. So notice over here, you can see the variable A and its value. So any variables I create, you'll see them appear over here. Notice also, after I perform this operation and hit enter, it prints out the variable name and its value. So that's the default behavior when you're assigning values to variables. Standard mathematical functions are available. For example, square root. So now if obviously B appear over here. Now, before I show another example, notice also, okay, here we just had an integer. Here we have a non-integer, and notice it only displays 5 significant digits, or 4 decimal places. That's the default appearance. But if I do format long, and now I'm going to use another mathematical function. I'll take the exponential of a, and now we see we have a lot more decimal places. So 15 decimal places shown. Notice it also uses scientific notation for numbers except ones like this, for instance. All right. And then, okay. So for multiplication, you have to use the asterisk. A common mistake is assuming that you would understand what 2a means, just because that's how you would write it on paper. Got to remember the asterisk for multiplication. Because if I did this, so here it's going to tell you that you have an invalid expression, and it's a syntax error. And actually, it tries to figure out what you really meant to do. So in this case, it had the right idea. Okay, so I'll go ahead and let it do that. And then, this is fairly intuitive. The up arrow is for exponentiation. I said b equal to the square root of a earlier, which is 7. So if I square b, then I should get 7. But notice it's not exactly 7. There's a little bit of error here. And this goes to what I mentioned last time, that any arithmetic operation is going to involve at least some error. It's going to be pretty small, so this is very close to 7. The error in this case is like 10 to the minus 15. But still something to keep in mind. So if I go back to format short, and display a again. So here I can display the value of a variable by just typing its name at the prompt. So notice before, if I scroll up to where I first set a equal to 3 plus 4, it just showed exactly 7. So this is exactly 7 in the representation of floating point numbers. But this is not. It's not exactly 7. Because as you saw here, there's a little bit of error. So that's why it shows as 7.0000. All right. Questions so far?
Yeah, kind of a weird question. In my MATLAB window, I've got the workspace on the right side with all of the variables. How do you get that to show the command history?
Oh, okay. Let's see. It might be different for you, like if you're on Windows versus Mac, which is what I'm on. Like for example, if I want to change things, I can select layout, and I can select for command history whether I want that or not.
Okay.
So yeah.
I see. Thank you.
Yep. All righty. Okay. So now, I should mention how MATLAB came to be in the first place. So it was invented by Cleve Moeller, who at one time was a professor. So in the early 80s, he was visiting Stanford University and teaching the numerical linear algebra course there, which was normally taught by Gene Golub, who was, Gene Golub passed away in 2007. He was arguably, or maybe inarguably, the foremost researcher in the world when it came to numerical linear algebra, matrix algorithms, etc. He was also my advisor. So at this time in the 80s, he was on sabbatical, so Cleve Moeller took over teaching the course. And he wanted to make it possible for the students to experiment with the numerical linear algebra algorithms that he was teaching about. So he developed some rudimentary software for them to create matrices and apply algorithms to them and so forth. And that was, and so MATLAB grew out of that. So MATLAB means matrix laboratory. So that's what he was creating for them. And then eventually the company, the MathWorks, was formed. And so he left academia and was their chief scientist, which I believe he still is.
And big money.
What?
And big money.
Yeah. So that's what I need to show you now is how to, at least the simplest ways to create matrices. Okay. So as an example, I'm going to create a 2x2 matrix here. So we have 1, 0, 0, 2. So notice I type all the entries on a row, end the row with semicolon, and then type the entries for the next row. Now, in this case, I've separated the entries by spaces, but you can also separate them by commas. And sometimes that's a good idea to make sure that if you have complicated expressions for your entries, just make sure that MATLAB doesn't misinterpret what you're wanting for your matrix. So I'm going to create another one, also 2x2. Okay, and then you can carry out matrix arithmetic just like for numbers. So I'll go ahead and do matrix sums. Now notice here how it named the result. ANS, short for answer. Because notice, when I did A plus B, I did not assign the result to any variable. So whenever you create an expression and it's not assigned to a variable, it's stored under ANS. Whereas here I said A equals this, B equals this, so we're assigned to A and B, which notice you can see those over here. But now we have a special variable ANS that's equal to the sum. So you can actually use ANS as a variable. So for example, if I take 2 times ANS, then it'll carry out the operation, multiplying all the entries of this ANS by 2. But notice now, ANS is overwritten. So if you're going to do that, if you're too lazy to assign all your expressions to variables, want to use ANS, fine, you can do that. I have done that sometimes. But be careful, because ANS is now equal to this, as you can also see over here. Okay. So, all right, so now I'm going to actually assign A plus B to a variable C. Okay. You can do scalar multiplication of matrices in a nice intuitive way. And also other operations like subtraction or multiplication, as long as the operation makes sense mathematically. In this case, we have 2x2 matrices, so certainly that's fine. Now, you can also create, of course, one-dimensional arrays. I want to create a column vector now. So 4, semicolon 5, semicolon 6. So now I have a column vector of length 3. If I had not put the semicolons here, it would be a row vector. So now, let's suppose I want to perform this operation. A times W. Well, A, created earlier, you see it over here, it's a 2x2 matrix, and this is a 3x1 vector. Well, that operation does not make sense, so MATLAB will tell you if you try something like that. Now here I've shown you where MATLAB will not let you perform operations that do not make sense mathematically. However, there's one important exception to that I actually found out the hard way, and I want to take a little time to point it out to you all too, because it leads to a very common mistake. So here I have W, column vector. Now I'm going to create another vector, I'll call it Z, a row vector. Now, let's suppose I want to do W minus Z. Mathematically, does not make sense. This row vector minus a column vector. But I'm going to go ahead and tell MATLAB to do it anyway, and let's see what happens. didn't expect that, did you?
Oh.
So,
Oh.
yeah.
3 by 3 matrices.
Yeah, so keep in mind, I'm going to put W back up. So if W is this and Z is this, can anyone figure out where on earth they got these numbers? What logic is there to? Did anyone figure that out?
Okay, so if I do the subtraction on every entry of W to subtract by Z.
Yes.
So
So this is a matrix of all possible differences of elements of W minus elements of Z. And this is helpful, for instance, for creating what are known as distance matrices that come from expressions like this. So and I imagine that's why they did that. Whereas if I had done W plus Z, you would do all possible sums. Now, things I didn't know they were doing that because it was not always this way. It used to be an error. So here's a problem. Let's suppose you have some rather complicated code that's working with all kinds of vectors, and in one situation, you're supposed to make something a column vector, but you make a mistake and it ends up being a row vector. And then you perform some operation with another column vector later on. And that mistake previously would be caught, but now it's not caught. Instead, you get a matrix, and who knows what happens with your code after that. So I've often got into situations with my students where their code is not working, and we have no idea why. There is no error message. And eventually you figure out, like, oh, you got to make this a column vector instead of a row vector or something like that. And yeah, it's really maddening. So I understand why they've changed this behavior, but I am not in favor of it. Okay. So MATLAB will tell you where you're going wrong mathematically most of the time. All right. Okay. Now, let's talk about, we have several variables over here now. Here's how you get some information about the variables that you have. So whose command. So this lists all the variables you currently have in your workspace, same as over here. And what kind of object it is. Is it a matrix? Is it a somewhat of rows and columns? And notice the bytes over here. So here, A is just a number. It occupies 8 bytes. So a double precision floating point number, which is the default format for working with real numbers, holds 8 bytes. And I'll get into that more later when we get to chapter 2. So here we have a 2 by 2 matrix. That's 4 entries, 8 bytes each, so 32 bytes total. So you get an idea of how much memory your variables are taking up. Okay. Now, there's also a command who, but that is just a shorter form of who that gives lot less information. It just tells you what your variables are. Actually, there's some other commands. Okay, so let's see what we got here. Okay. Oh, what does nothing? Okay.
Why? Where?
Okay. Oh, so I don't have simulated stuff. Okay. Okay, we don't have when. We don't have how. We do have why. Why puts together a random sentence to explain your difficulties. And it's rather strange choices. But why? Okay.
That's a good question.
Yeah, so when you're frustrated, this is something you can have some fun with. Yeah. All right.
Last one actually kind of works.
Yeah. Okay. Oh, you know what? Yeah, I can take a break at this point, because we're 38 minutes in. So, okay, I can pause the recording, I believe. I can't do this in Teams, but I can do it here. Okay, we're back. I'm not going to get as far as I wanted, but that's okay. Still 3 more class periods for this. Okay. Oops. All right, complex numbers. But you can also do, so I'm going to create a vector where one of the elements is complex number. Here's what I can do it: 3 plus 4i, where I is the imaginary unit, square root of -1. Okay, so notice here for all dice, it shows shows an imaginary part, even though the first entry is real. And now, if I do whos again, so notice Z has 2 elements, 32 total bytes. So 16 bytes per element. 8 for the real part, 8 for the imaginary part. So a thing to keep in mind is, if you have a vector or matrix, and even one number is a complex number, it declares the whole thing complex. Notice it says complex over here. So it takes up twice the space. Sometimes it happens where you perform a computation, and the result is really supposed to be a real number, but perhaps due to round-off error, there is an imaginary part. And so now it's taking up twice as much space. And it can be wasteful. The fast Fourier transform and inverse fast Fourier transform are examples of that, because there's always rounding error. Now, what you can do is extract real imaginary parts. So if I do, for instance, y is the real part of z, and then I can do the imaginary part of z, which is still real results, so it takes out the I. And so here, the first one is 0 because the first element of z is a real number. So this has no imaginary parts. Now these are taking up the normal amount of storage for real numbers. So if you have a vector that isn't really supposed to be complex, but it has these trivial imaginary parts, you can just take real of it and get rid of the wasted storage. Alrighty. So this is an example, actually I think it's the first example of in what I've done here today, of a function, using a function in MATLAB. So real and imag are functions. Z is input argument, and Y is an output argument. So later we'll see more elaborate functions that take multiple inputs and can return multiple outputs, but this is a general syntax for them. So output is equal to function name, and then any inputs are given in parentheses. If there are more than one of them, it's a comma separated list. And like I said, you'll see examples of that later on. Now, I've shown you a way to create matrices, but that's very limited. There are certain matrices that we'd like to have for convenience. For example, this command right here, the ones function, generates a matrix where the number of rows is the first argument and the number of columns is the second argument. So 6 by 5 matrix where all elements are equal to 1. Now, that's what the default usage of ones. Or if I do this, I'd be careful about this. You might think this will create a one-dimensional array, but it actually doesn't. Square matrix. So if you cast this one argument, it assumes that that's the number of rows and columns. If you want a vector, like a row vector would have one row. A column vector would have one column. There's also a zeros function that is used in the same way to create a zero matrix. And then, like I was saying earlier, if you want a vector, I can do something like this. So this will give me 1 row and 6 columns. So it gives me, whoops, that's supposed to be zeros. Okay, the 6 elements vector of zeros. Another one is rand. What random numbers, so this is a 3 by 2 matrix of random numbers. Now, if you want to know about distribution, they're uniformly distributed. In the interval 0, 1. One of the homework problems is, okay, suppose you want random numbers in the interval -1 to 1. Then how do you make use of rand? And what would you have to do to make that happen? Okay. So these are functions I find myself using quite often to create the matrices that I need. Now, sometimes you need a range of numbers. This will be particularly important in loops, for example, which we'll come to later. Like if I want to create a vector consisting of the numbers 1 to 10, well, I could do this. All right, that's fine. Now, suppose I want the numbers 1 to 100. If I want to do that, no, but I don't have to. I can do the following. These 1 colon 10. And that'll do the same thing. Okay, now suppose you don't want just 1 to 10. What if you want only the odd numbers? I can do this. So if I have, colon operator, if I have 3 arguments, the first element is a start, the last element is finish, the middle argument is a spacing. So this will start at 1 and then hop 2 until reaching 10. So after we get 9, the next one would be 11, but that would be past 10, so we don't include it. You also go backwards. Start at 10 and go backwards by 2. Now, the thing to be careful about is you have to, so if you're going to go backwards, you want your largest element to be first. If I did this instead, 1 minus 2, 10, you get nothing. So if your spacing is positive, the default is 1, your spacing is positive, you get nothing if a finish is less than a start. Similar idea here, only in reverse. That if the start is less than a finish and your spacing is negative, again, you will get nothing. So notice if I do whose again and look at Z here, Z is a 1 by 0 matrix, occupies no storage. All right. Okay. Now, I'm going to go ahead and create another random matrix, 3 by 3. And as I pointed out before, when I do this, it prints out the contents of A. No big deal here. But it leads to an unpleasant experience if you're working with something larger. Like I do rand 500. Watch all that output fly by. By the way, I did this the last time I taught this class 2 years ago. And what I wanted to do for today's class was print out the diary from 2 years ago to have handy here. And I forgot that I had done this in there and almost sent 1,000 pages to the printer. Thankfully, I caught it in time, although actually I forgot to bring that here. Yeah, so I had to edit that out. It took a while. After that, there was practically nothing left. But the thing is, we don't want to have that happen. We don't have this gratuitous output. So to suppress output, use semicolon. Now, semicolon is something that's required in a lot of programming languages. But here it's optional, but it certainly serves a purpose. So what I often do when I'm writing code works yet, I might not use semicolons, but it'll print out things as they're computed. So I can see how it's behaving, make sure it's correct. And then once I know the code is working, then I put semicolons in. So it's not giving all this output that I no longer need. Okay.
I'm now picturing you dropping 1,000-page booklets in front of us before class starts. Like how intimidating that would be.
Yeah. It's like a law school movie with paper chase.
Just one copy for each person.
Okay.
And they're already there.
Memorize these numbers.
Now, you can also build up matrices from other matrices. So I'm going to create the matrices to show you. I'll do it 2 by 2. And then there's a 2 by 3. A semicolon this time. And then this is a matrix that is 3 by 2. Okay, so A is 2 by 2, B is 2 by 3, C is 3 by 2. Okay. Now, here's what I can do. If I form a matrix, I can form a matrix by horizontal or vertical concatenation. So A is 2 by 2, B is 2 by 3. So if I put them next to each other, I get a matrix that is 2 by 5. And I can also concatenate vertically. So A is 2 by 2, C is 3 by 2. So I put them on top of each other, I stack them vertically, and the result is 5 by 2. There's a homework problem that has you try other concatenation operations. You can't concatenate just anything. There are certain rules to be followed there, so that homework problem will ask you about that. But I find myself using this often to build matrices. Here's another example. I can use an empty matrix using just a pair of square brackets with nothing in between. So this has nothing in it. And then I can grow x by adding numbers onto it. So here I put on a 1, and then I take that x and tack on a 2. Or have as many numbers as I want. I'll tack on a 3, 4, and 5. So it'll iteratively build up a row vector. Sometimes I do this where I have a vector and I start with nothing, and then I have a vector grow during the loop, each time adding on one element. I should point out though, from a programmer's point of view, it's inconvenient. Not the most efficient, and the reason why is, like take this operation here. X is a concatenation of x with 3, 4, 5. X has previously been allocated to hold these two entries, 1 and 2. So when it does this, it will deallocate this x and then allocate a new one that will have 1, 2, 3, 4, 5. So if you're doing this in a loop where you're constantly growing the size of matrix, so MATLAB makes it very easy to have matrices grow automatically to accommodate whatever entries you want to put in them. But if you have it grow in this manner, then that repeated deallocation and reallocation to a different size will drastically slow down your code. And MATLAB will actually warn you about this. That's something I'll show you when we get to writing MATLAB code in the editor. What it suggests is pre-allocating to make your code faster. So like if you use the zeros function to allocate a matrix where you don't know what you want to put it in yet, then when you do go to put it in later, it'll be much more efficient than growing it like this. It can be cumbersome, but still more efficient. So there's a trade-off there. So what's convenient from a typing code point of view is not necessarily good for a code running point of view, which in the end is more important. Now I've shown you how to build matrices, but what about accessing matrices or changing matrices? Okay. So what I'll do here is, okay, so I have this matrix from before. Okay. How do I access an individual entry of a matrix? Use this notation. Use parentheses. By contrast, some languages want square brackets. And I specified a row index, comma, the column index. So that would just be a scalar 3 in this case. Now that's for accessing an individual entry. Notice indexing in MATLAB is 1-based, whereas some languages like C and C++ are 0-based. So the elements of an array of length n are indexed 1, 2, 3, etc. up to n. That's something to keep in mind. There's a lot of the algorithms, like in math books, for instance, described on paper, might use 0-based indexing because that might have made more sense intuitively. But then you have to implement that in MATLAB, and it uses 1-based indexing, and you have an adjustment to make. Now, I'll show you other ways to access or change entries of a matrix, so I'll create a random one to work with. If I do this, for example, row 1, and then I use a range of indices, because 1:3 is the same as 1, 2, 3. Prints the first row. Or it extracts first row, and that's the result of the expression. In this case, it's stored in ands. Similarly, I can do whatever range I like. So rows 1 and 2, column 1. So that prints the first 2 entries of the first column. I can do any submatrix I want. I can have ranges of both rows and columns. So 1:2, 1:2. This will print the 2x2 submatrix from the upper left. Now, if you want a whole row or whole column, you can do what I described here. Like this does the entire first row. But in a more convenient way, like if I do this, colon by itself is all indices that are appropriate in that context. So in this case, it's all rows, column 3. That'll be the entire third column. I can certainly do that with rows also, like if I want the entire first row. Yet another convenience is, like, suppose I want the last column. I can use a special index n. That will automatically be interpreted to be the last valid index. So this is a way to print the last column of A. So it's equivalent to the third column, since A is 3 by 3 in this case. You can use n wherever you want in indices, index ranges. I could do like row 2 to the bottom, column 1. So this is A21 and A31, because n would be 3 in this case. Really, keep in mind, 2:n, that's a row vector. Anytime you use a colon operator, you saw the examples before, it produces a row vector. You can use any row vector to specify row or column indices. You don't have to be in order. I can do this, for example. Suppose I want rows 1 and 3 in their entirety. And that's the first row, and then the third row. So that submatrix is produced. Certainly you can do the same thing with columns. So, like I said, don't even have to be in order. So this is third column followed by second column. So it'll take into account the order in which you list them. And then those are the columns that it would extract in this case. 5 by 5, I can do, for instance, rows 1, 4, 5, or 1, 4, 3, and then columns 5 and 2. So we see what it produces. So it's going to look at rows 1, 4, 3, but only columns 5 and 2. So for instance, this first element is the 1, 5 entry that comes from here. And then here we have the 4, 5 down here, and then 3, 5 over here. And then here, 1, 4, 3 entries from the second column. But you'll see over here. So whatever you need to extract from a matrix, in whatever order, you can do that. Questions about that? One of the homework problems is use this kind of indexing to take a matrix and reverse rows and columns. And keep in mind what I did with the colon operator earlier. You can apply that in this case to accomplish that.
Or use flip.
What?
Or use flip.
All right.
Actually, I do have a question.
Yeah.
You showed the end index earlier. Can
Yeah.
you do arithmetic with that, or is it only the end? Like, would you get the second to last index?
I have done that actually. You can. So for instance, suppose you want the second to last index, you can do n to minus 1. Good question. Other questions? Okay, actually, this is the last thing I'm going to cover today. Transpose. Now, as I mentioned before, we used a colon operator. If I did this, and that would give me a row vector, so 0, 0.1, 0.2, 0.3, etc., up to 1. But suppose I want a column vector. This, the quote here, or apostrophe, forms transpose. So that gives me a column vector. Although, I have to be careful about that, because well, I said it was not entirely precise. It will transpose a vector or matrix of real numbers. So to explain why I have to qualify it that way, I'll show you an example. I'll just bring back this complex vector from earlier. Okay. So here we have this complex vector as a column vector. So let's suppose I want a row vector. Okay, fine, I'll go ahead and transpose. Gave me a row vector, but yes. Notice 3 plus 4i over here became 3 minus 4i over here. So it's called a Hermitian transpose. And what that means is, so mathematically, if I have a matrix A, so normally in linear algebra textbooks, A superscript T is A transpose, and the entries of that are Aij is equal to, or I should say, A transpose Ij is equal to A Ji. So that's the ordinary transpose. In most linear algebra textbooks, the superscript of H, or sometimes a star is used to indicate adjoint. A Hermitian transpose has entries, and that is the complex conjugate. I'd like to put a bar in here, but I can't do that in this command window. So it takes a transpose, and then it takes a complex conjugate. So the question is, what if you don't want the complex conjugate? What if you only want to do pure transposing? Here's a way to do that. It's Z dot transpose. And there it preserves the 3 plus 4i. So something to keep in mind when you are taking transposes and if you're working with complex values at all, and if all you want to do is change a row to a column, for instance, or vice versa, make sure you know which transpose operation you want. Now you might wonder, why is Hermitian transpose the default? You'd think that the default should be just plain old transposing. The reason why is a lot of matrix algorithms that are, when presented for real vectors and matrices, whenever a transpose is called for, if you're going to take that concept or algorithm and generalize it to complex matrices, generally it's the Hermitian transpose that is needed for proper generalization. For example, if you have column vectors x and y, x transpose y, if they're real, x transpose y is the dot product, or standard inner product. If you want the standard inner product of complex vectors, it's x Hermitian transpose y, to satisfy all the properties of an inner product. So that's why the default is Hermitian transpose. So beware of that. Okay. So in general, 3x2 matrix here. This is real. Then a transpose, there'll just be the ordinary transpose. So 3x2 goes over to a 2x3. There is a transpose function. I could also do transpose. They would do the same thing. So on the subject of complex conjugation, if I make a random, think of a complex number. So if I have just a number, if I only want to conjugate, I can just do that. That would work. But I can also do conj, function, applied to z, would do the same thing. And that can be helpful if you have a complex matrix. Suppose you have a matrix of complex numbers and you want them all conjugated, but you don't want to change the shape. You don't want to change rows to columns. You don't want to transpose the thing. You just do conj, and that'll keep the shape and conjugate all the elements. All right. I have 1 minute left. Well, this is all I plan to present, and I'll continue the tutorial into next week. But certainly, any questions? Including from anyone who's viewing elsewhere. Feel free to unmute and ask a question also.
If we wanted to start the homework, would this text file be what we would turn in?
Okay, so based on what I've covered so far, see, I've gotten up to like problem exploration 12 or so. So what you can do is, if the exploration calls for doing things at the MATLAB prompt, what I would suggest is using a diary command like I just did. Oh yeah, that reminds me. Diary off is how I stop logging what I do. So now the file is complete. So if you do a diary and put your commands in there, you can submit that. That'll work for any problems that call for doing things at the prompt. Some of the later problems will involve writing MATLAB code in M files, which I'll cover later, and then those M files will also be submitted. So you'll be submitting a number of files. I'll leave it up to you is whether you want to have like one diary that has everything, or some students have submitted like a separate diary for each problem. That's fine too. I should mention that if I've just turned off my diary. If I use the same diary command to turn diary on again with the same file, it will append. So it won't wipe out what you had before. You can build up a diary during multiple MATLAB sessions. and also like, if you do a bunch of things in MATLAB and you use a diary to record it, and you want to submit that for the assignment, but it's a mess, that's okay. You can go ahead and edit it in any ordinary text editor. Like if you did some commands that went wrong and you don't want to submit that, you can edit that out. Yeah. And please do if that happens. What I also recommend is, like if you're going to have multiple things in one diary file, use comments like I did here with a percent sign. Like say like percent sign 1.2.4, and so I can navigate through it and see, oh, here's where you did this problem. Other questions?
Professor.
Yeah.
So I want to ask you if you could do us a favor to share the PDF file of the textbook with us. I know you are the author of the textbook.
I don't know if my publisher would approve of that. I seriously, I think.
Okay.
Yeah, I've nominated practice. That'd be unfair to 2019 and 2017 students.
Okay.
Yeah.
So can you upload the problem of maybe the scan the video picture of the program set onto the campus?
Oh,
You just yes sketch.
I mean like the problems.
Yes, just the homework problem.
Okay. Because keep in mind that the quizzes. Because notice it in Canvas. I'll show you. Okay, yeah, so what you're referring to are these homeworks down here.
Yeah.
So we have these down here. Now the questions for these are in Canvas.
Okay.
But the material that you would read through to answer the questions, well, you can have your cameras from class. But it's also in the book.
Okay.
So, yeah. So.
I see. Thank you.
Okay. All right. Other questions? Okay. Or anybody can ask me after. But. Okay.